Hello audience. In this video we're going to take an old Delcotron alternator, convert it to one-wire self-exciting 6-volt positive ground, and then we're going to install it on this car. This is a 1930 Ford Model A. Now if you know me, you're probably thinking, this is kind of an unusual project for me. I'm usually one to save the old generators even when I have more than enough excuse not to. Well, the reason is, they have these do-it-yourself kits out there where you can rebuild an alternator while converting it to 6-volt positive ground or other configurations, and I've always been somewhat curious about them. I figured they might be fun to work with. So the owner of this car, he doesn't really care what it has as long as the charging system works. So I used it as an excuse to buy one, and here it is. Got it off eBay for about 50 bucks. And I got a few old Delcotron alternators out here I can work with. So we're going to convert it, and then we're going to throw it on this car and see if it works. And while working on it, I'm going to try to explain the basic function of each component and what it does. I'm not trying to teach anyone how to do an alternator conversion the right way or anything. I'm just doing this for fun more than anything else. So let's get started. Now this is what we're going to use. This was made by Delco-Remy, commonly referred to as a Delcotron, and these were used on most General Motors cars through pretty much the 70s decade. I can't tell you specifically when these were introduced or replaced, reason being the internet, various repair manuals, the experts, the parts houses, no one can seem to agree on specifically what model years these were used. Now, when I need one of these, usually what I do is I go to O'Reilly and order one for a 1975 Chevrolet Nova, and this is what they give me. This series Delcotron is commonly referred to as a 10SI. They're 12 volt negative ground and have a capacity of about 72 amps, more or less. And they've pretty much become the standard component for aftermarket, universal, custom charging systems. There's a lot of aftermarket kits for them and various things. Now this one I was using on the Falcon before I could get the generator to work, and I think that's why I bought this one. It's already been rebuilt. Now, using a rebuilt one is pretty much a waste of money because just about everything I paid for we're going to replace anyway. It would be more economical to get one of these out of the junkyard or from a swap meet, but this one I don't have a use for it, so we use it anyway. Now this is the previous generation Delcotron, and I believe the first generation. This was used through most of the 60s decade. It's referred to as a 10DN. They are pretty similar, and I've confused them in the past. Functionally, the big difference between the two is this one requires a separate voltage regulator. This one, the regulator is built into it. Now this one, if you hook it up without the regulator, it won't do anything. Now from the outside, yeah, they look pretty similar. The easy way to tell the difference is the back of them. Now this one, the earlier one, the diode pack is pretty visible. It's got 6 individual diodes, 3 of them pressed into the housing, 3 of them on a separate plate inside, and the plug is on the back of the housing. The later one, the 10SI, the plug is on the side, and this is the newer style diode pack. As you can see the fins inside here. This is all one module, pretty much. Now this is specifically made for a 10SI Delcotron alternator, and it's 6-volt positive ground, one-wire self-exciting. Now I ordered the positive ground kit because the card's going on is originally 6 volt positive ground. But when you're ordering these, it's important to read the full description because some of these are negative ground. They make kits for 8 volts and even 24 volts and a variety of different stuff. Now, like I said, it's 1 wire self-exciting instead of 3 wires, but I'll explain more about that later on. We'll start with taking this one apart. Put that aside for now. And here's all the stuff. Alright, it's sometime later. I painted the housings black because that's what all the cool Model A people do. And because this thing is now modified, I gave it some identification from the outside. I painted 6 volt on it, added a minus where the battery terminal is, and near the ground terminal there's a minus embossed in it, so I painted over it and made it a plus. And now we'll begin assembling it. Now here's the new rectifier compared with the old one. Now the purpose of this is the stator puts out alternating current. In other words, the current just pulses from one direction to the other and needs to be converted to direct current to charge the battery. So each of these terminals have a pair of diodes on each side, so that current can only flow one direction. So when the current is positive, it's blocked from going here and goes to this side. But when the current is negative, it's blocked from coming from here and it comes from this side. Now apparently for 6 volts you need a different rectifier for some reason. In addition to that, this one is positive ground. So the diodes are hooked up the other way, so the current goes the other direction. So the side that grounds against the housing is the positive, and the one that goes to the power terminal is negative. Exact opposite of this one. This installs just like the old one. And here's the new power terminal. Now it's got to have an insulator on it so it doesn't touch ground. The rectifier has a plastic piece on the bottom of it so that doesn't touch ground. I'm not going to tighten this all the way down just yet. There's a wire that's supposed to go on it. Now here's the old voltage regulator that came out of it, and I pried the lid off of it so you can see it's got a circuit board in it. Now, I'm going to talk a little about this before we put the new one in. Now this, obviously, it regulates the voltage to 12 volts and regulates the amount of amps. It also monitors the alternator's current charging rate and monitors the condition of the battery and sets the charging rate accordingly. Now, this one's the power terminal, and it has this thing that goes on it. This gets the output from the stator, and it has its own little rectifier on it. So this gets positive current. This is how it monitors its own charging rate, and this is also the power source for the armature. There's one armature brush, gets power from there. The other brush goes to this terminal. Now the way it regulates its own charge is it regulates how much current goes through the armature and does it through this terminal. And then this one's ground. Now on a normal 3-wire Delcotron, this terminal, which is number 1, it goes to the ignition switch, usually through a warning light. And what that does is it powers the armature and powers the regulator when it's first starting up and it's not producing anything. After it starts charging, it receives power from here, and then it can power itself. Now without this hooked up, it can still turn itself on. The armature will have some magnetic field left in it from when it was charging last time, and it can charge from that, but it'll be really weak. So they got to get the RPM up really fast, and then when it eventually gets current going, it feeds back into here. Then it can power the armature and power itself. That's why these one-wire self-exciting armatures, you got to start up the engine and rev it up a little bit for it to work. Now this terminal, the second one, this goes to a wire that goes as close to the battery as possible, so it monitors the battery condition, so it can regulate the charging rate accordingly. Now here's the new one. Obviously it's made to regulate it to 6 volts instead of 12. I have no idea how many amps. I couldn't find any information on that anywhere, so I'll just have to wait and see. Now like I said, this one has a terminal for monitoring the battery condition. This one, even though it has a terminal, the instructions say not to hook anything up to it. So I'm guessing the regulator is different in it somehow. I really have no idea, but we'll install it the way they said. Another thing is the original regulator had a resistor going from power to ground. Well, the new one doesn't have it, and it doesn't mention that in the instructions, so we're not going to reuse it. And then this part, which, like I said, connects the stator output to this terminal. And these both get insulated screws. Now this, we're setting it up positive ground, but the thing is the regulator is put together negative ground, just like the original. Now because the rectifier, the positive current is now going to the housing. Now, like I said, this terminal is ground, so we don't want it to go to ground. Now, the original just had a regular screw going to it. This one has another insulated screw to go there, and it comes with this wire to connect this terminal to the battery terminal, because that's now negative. And now the stator. Mentioned in the instructions to make sure these wires are not touching any part of the rectifier, and they're not, so it's pretty good. Now this section is finished, so we're just ready for the final assembly. This one has kind of a snug fit, so I'm drawing it down slowly with the bolts. And that's it. So now I just pull the pin that's holding the brushes back. And that's it. Should work. Ready to install now. I reused the old bearings because it probably already had new ones in it. And here's the mounting kit. So we'll assemble this and see how it looks. Okay, we've hit some problems. Now, first of all, the pulleys are not even close to lining up. This one is noticeably further back than this one, which is strange because this pulley is made just for Model A's. Another problem is the bracket is kind of flimsy, so when you tension it, it actually twists the mounting. Now, I set this up on a different timing cover to show you what's going on here. It's got two of these links, one on each side, that just bolt on. And there's no stop on it, there's nothing like that, so I'm not sure if it's supposed to go like this, like this, like this. Is it supposed to pivot from here or here? And another thing is there's nothing holding these two links together, so nothing is preventing them from twisting. On top of all that, like I said, this is too far forward, the pulleys don't line up. So I'm going to need to redesign this a little bit. And I redesigned it a little. Now, the first thing I did was I shimmed it back here to lengthen this so that the alternator can sit back. You need to sit back about 1/4 of an inch. And I also welded these braces to it, so now this is rigid. It can't twist anymore. And after playing with the tensioner and all that, I discovered this wanted to be straight up and down, and it should pivot from here. So this brace, I welded it on so it's bottoming out against the timing cover so it can't twist in. And now here it is, fully assembled. Now, even though I had to redo the bracket quite a bit, I don't feel too bad about it because this kit was only $30 and the tensioner alone is worth that to me, which I didn't have to modify at all. Looks like it'll work really well. So next we'll put it on the car and see what happens. And now it's installed. The pulleys more or less line up. The belt is more or less pretty tight. And now the next problem, stock wiring harness. The ends won't fit on the terminal. I ended up replacing the end on the wire with a bigger one. And one thing I'll point out is this stud, come to find out, is metric. The head on this is 10 millimeters. So anyway, it's all wired up, so I'll start it up and see what happens. Now the last thing to do is install this cap to go over the terminals. Or try to install it. And it's going to be a struggle every step of the way. I had to bend these tabs back a little so they fit in this groove. Good enough. I drove it around today and it stayed working. It seems to be regulated at about 15 amps, which is about as much as I would want it to charge because it still has mostly all the stock wiring. If it charges too much, it can burn out the ammeter and overload the wiring. And if that was the case, I'd probably have to make a new charging wiring harness out of thicker gauge wire and bypass the ammeter, which was more work than I wanted to get into with this. So it all pretty much worked out. I'm probably going to leave this car the way it is because it works that way, but in the future I'm probably not going to do another alternator conversion on these. Reason being, the generators work just fine. I can get good ones for cheap, sometimes free. They're easy to get working, and they work. They're usually pretty dependable. But like I said, I did this entirely for fun and for an excuse to rebuild a Delcotron alternator, and it was very educational. So thank you for watching. We'll see you next time.